NASA has detected a mysterious object in our solar system that continues to baffle even the most seasoned astronomers. Ever since Oumuamua passed through our cosmic neighborhood a few years ago, speculation about its true nature has run wild. Now, two scientists believe they may have finally unraveled the mystery behind this interstellar visitor. Is it just a naturally occurring object, or could the renowned Harvard professor be right? Could it actually be an alien spacecraft? Stick with us until the end as we explore the possibilities. What started as a groundbreaking discovery quickly evolved into one of the most puzzling space enigmas of our era. So, what exactly happened? To understand that, we need to remember one thing: in the vastness of space, nothing escapes scrutiny. Countless asteroids, comets, and meteoroids routinely draw the attention of astronomers. Yet what the Pan-STARRS telescope in Hawaii detected on October 19, 2017, was unlike anything seen before. Its origin? Not from our solar system. And so it happened that the celestial object later named Oumuamua became the first known interstellar visitor ever detected. Yet, it wasn't until some time later that scientists began to realize just how mysterious this unexpected traveler truly was. At first, experts assumed it was nothing more than an ordinary comet. However, that theory quickly began to fall apart. Oumuamua displayed strange characteristics and an unusual flight path that didn't match any known classification. Normally, a comet would exhibit a visible tail and a surrounding cloud of gas and dust called a coma, formed as it nears the sun. But detailed observations revealed none of these typical features. Even more puzzling was its trajectory. By the time it was discovered, Oumuamua was already on its way out of the solar system, heading back into interstellar space. It had passed Earth 5 days earlier at a distance of about 24 million kilometers. Prior to that, on September 2, 2017, it had entered the solar system almost perpendicular to the orbital planes of the planets, an entry angle that only deepened the mystery. Reconstructing its trajectory, scientists traced Oumuamua's origin to somewhere in the constellation Lyra. Just 7 days after entering our solar system, the object made a close approach to the Sun, coming within 37.6 million kilometers, before sharply turning and heading back into the depths of space. But what followed was truly unexpected. Data from multiple observatories, including the Hubble Space Telescope, uncovered something astonishing. Oumuamua had accelerated as it swung around the Sun. This unanticipated boost in speed left scientists both amazed and puzzled. The deviation in its path, one that couldn't be explained by gravity alone, quickly became the subject of bold and adventurous theories. Still, astronomers first sought more conventional explanations, such as outgassing, where heat from the sun causes volatile materials to escape the surface, propelling the object forward. However, two major problems challenged this theory. First, no dust or gas was observed near Oumuamua. Second, outgassing typically alters an object's rotation, but no such rotational change was detected. In fact, when it came to rotation, Oumuamua defied every known behavior, making this interstellar visitor even more enigmatic than anyone had imagined. Instead of rotating smoothly along a primary axis, this object appears to be tumbling chaotically through space. Scientists reached this conclusion after studying unusual fluctuations in the object's brightness, changes that occur in regular intervals and are unusually intense. Based on this, researchers believe that Oumuamua likely has an elongated, cigar-like shape. However, its exact size remains uncertain, as it depends on various factors that scientists have yet to fully understand. Estimates suggest it could be anywhere from 100 to 800 meters in length. Adding to the mystery, no dust was detected around the object, a surprising discovery that sparked speculation it might be composed almost entirely of metal. But the intrigue doesn't stop there. Some experts went further, proposing that Oumuamua might not be natural at all, but instead the product of an extraterrestrial civilization. The spaceship theory. If you think this idea came from some fringe online forum, think again. This theory was actually proposed by Avi Loeb, a prominent Israeli-American astrophysicist from Harvard University. Along with his colleague Shmuel Bialy, Loeb suggested that Oumuamua displays characteristics consistent with an artificial spacecraft. Specifically, its unusual trajectory and the absence of dust could be explained by the object being an ultra-thin solar sail, a technology hypothetically used for interstellar travel. This, in essence, is an artificial structure propelled by the radiation pressure of the Sun, or perhaps another star. While this concept remains in its early stages within human science, researcher Loeb suggests it's possible that an advanced extraterrestrial civilization may have already brought it to life and developed it far beyond our imagination. The solar sail, estimated to be just 0.3 to 0.9 millimeters thick, would have an enormous surface area. This design would allow it to stay on course during its journey, unaffected by solar radiation pressure. But how does the broader scientific community view such a bold claim? In general, most scientists believe that Oumuamua's unusual behavior can be explained through natural causes. One leading theory proposes that the object is a fragment of a Pluto-like exoplanet, composed largely of frozen nitrogen. As it traveled through space, the heat caused its outer layers to melt, gradually shaping it into a flat, cigar-like form. Nevertheless, investigations conducted at the Green Bank Observatory in West Virginia in December 2017 revealed that the possibility of it being a spacecraft wasn't dismissed outright. It remained a hypothesis considered worth exploring. At the time, radio telescopes were used to scan Oumuamua for any signals that might hint at an artificial origin. After 4 observation blocks and 2 weeks of monitoring, however, the results were disappointing. No evidence of artificially generated signals was found. Had the mystery been solved? As the possibility of extraterrestrial propulsion technologies began to seem increasingly unlikely, astronomers turned to alternative explanations. It wasn't until March 2023 that a breakthrough was finally announced. The mystery of Oumuamua had been solved. And while the answer had little to do with solar sails or alien intelligence, it still left room for hope among those open to unconventional ideas. Ultimately, these are still theoretical models, plausible, but not directly confirmed by Oumuamua itself. Despite the absence of a visible dust coma and its puzzling acceleration, scientists Daryl Seligman and Jennifer Bergner managed to create a coherent theory that fits the data. According to their research, the most likely explanation is hydrogen propulsion. They reached this conclusion after analyzing a series of lab experiments from the 1970s to the 1990s. These experiments showed that water ice, when exposed to intense cosmic radiation, can break down into molecular hydrogen. As a celestial body like Oumuamua travels through interstellar space, it's essentially cooked by this radiation, producing hydrogen gas that could explain its strange movement. Given the evidence, it's reasonable to conclude that Oumuamua also produced hydrogen. The challenge, however, is that this hydrogen shouldn't have escaped into space right away. To explain the sudden acceleration after its pass around the Sun, researchers Sigman and Bergner proposed an interesting theory. The hydrogen was initially trapped within tiny pores in the ice. Their calculations supported this idea, showing that under interstellar conditions, most hydrogen formed within ice tends to remain locked in its water matrix. This situation only changes when the ice heats up to temperatures between -258 degrees Celsius and -33 degrees Celsius. Until that threshold is reached, the water ice remains amorphous, meaning its structure is disordered. But once warmed, it begins to crystallize. As Oumuamua entered the solar system, sunlight gradually warmed its surface. This caused the ice on its outer crust to change structure and open up pores, allowing the previously trapped hydrogen gas to escape. This release of hydrogen explains the object's acceleration, and also why it was so hard to detect. Since molecular hydrogen is nearly impossible to identify using spectroscopic analysis, the outgassing was invisible to researchers. Unlike typical comets, which produce dust and form a visible tail or coma during outgassing, Oumuamua released only hydrogen, leaving no visible trace behind. Even if the ice matrix contained dust, it's unlikely that it was expelled during outgassing. The key question now is whether this particular type of outgassing could account for the unexpected acceleration of the interstellar object. The answer is yes, but only if the object is relatively compact. For a body several kilometers in size, outgassing wouldn't significantly impact its motion. However, if Oumuamua is only around 100 meters long and 20 meters thick, the force from outgassing could have been strong enough to explain the acceleration that was observed.